Welcome back to another video. In this video, we're going to be talking about Punnett squares, how to do them, writing genotypic and phenotypic ratios, and all those kinds of things. If phenotype and genotype sound foreign to you, my advice to you would be to go back and watch the 7.1 lecture video, which does a deep dive on all things genetics in terms of intro, like dominant versus recessive, purebred versus hybrid, as well as a bunch of other different vocabulary. Okay, so if you have not gone back and watched those before watching this, I highly advise that you watch the video on 7.1. Okay, so today let's talk about Punnett squares. So we are given the cross homozygous dominant crossed with homozygous recessive. Okay, and so how I set this up is this is parent number one, and let's say that this is parent number two. Okay, so let's say that I'm going to put parent number one on the top column here. Okay, I'm going to split apart the two P's. So I have one capital P here, and I have one capital P here. All right, so that's one side. On the other side, I have two lowercase p's. Now, P's are a little bit confusing because it's hard to tell if they're going to be capitalized or not. So what I like to do is I like to put a line underneath P's. The same thing can be done with S's and some other letters that have similar shape, whether they're capitalized or not. But I'm just going to put a line underneath. So again, I put parent number two on this side, who's homozygous recessive, and parent number one on the top, who is homozygous dominant. Okay? So now what I'm going to do is I'm going to predict the offspring of this cross. Okay? So remember, Punnett squares, they show probability. Okay? How likely is it that a certain trait is going to be passed on? Okay? So with this information, I always put dominant letters first. So a big P will go first, and then I have a little p underneath. Okay? And what you'll come to realize is there might be a pattern in these crosses. So all of the following offspring are going to be heterozygous, or big P, little p. Okay? So looking at the genotype, okay? The reason why we have genotype down here is because we need to give a ratio. Okay? And there's multiple ways that you could do this. The first way is that you can list what is given. In other words, what genotype do you see in the boxes here, or in our Punnett square? Well, all you see is heterozygous. Okay? And so what I would say is that there are 4 out of a possible 4 that are heterozygous. Okay? Now, some people may want you to include, okay, how many homozygous recessive, how many homozygous dominants are there? In this particular video, I'm just going to show you how to do what is given, okay? So, with the phenotype, remember the phenotype is the physical characteristic. Let's say, for instance, that a capital P represents pink and a lowercase p represents white. So pink is dominant to white. Well, we would determine that if it's heterozygous, it has a big P. All of them are going to be pink, so I can put 4 out of 4, okay? So what I would like you to do is pause the video. These should be in your notes, all the following Punnett squares that we're going to do. Please pause this video, and let's go through and see if you can do this one on your own. So again, take a second, pause the video, and go ahead and give this one a try. All right, so if you pause the video and given it a try, I'm going to go ahead and do this one. So we have a big P up here, big P up here. This is my parent number one. And then I have a heterozygous over here. And again, I like to draw a line underneath my P. So that is parent number two. Okay, so I'm going to go ahead and do these crosses. We have 2 big P's here, 2 big P's here. Then I have a big P and a little p. Again, leaving or leading with the big P. The big P always goes first. And again, the same thing here. Okay, so for the genotype, there's a couple in there, right? There are 2 that are homozygous dominant. So this would be 2 out of 4. Okay, and there's another one. We have heterozygous ones in there, and there are 2 out of 4 of those as well. Okay, with the phenotype, I said pink versus white in the first one, so we'll stick with that. And if you count, this one is going to be pink, 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 and pink. So all of them are going to be pink. And so this is how you would correctly set up your ratios. So again, genotype, these are the letters that you find inside the boxes. And then phenotype, this is the physical trait. So in this case, we're comparing pink versus white. All of the following will be pink. Okay. So again, Punnett squares, what they do is they allow you to predict the likelihood of specific traits that are going to be passed on. So in this particular case, if we're looking at flower color, okay, pink is going to be passed on 100% of the time due to the genotypes of the parents. Okay? We're going to do one more. So again, if you want to pause the video, give it a try. I'm going to give you a couple seconds to do so. Awesome. So hopefully you gave it a try. In this case, we got two heterozygotes crossed together. Again, I'm going to put a line underneath. And we got over here, line underneath. So I have big P, big P, little p, big P, and little p, little p. Okay? So I'm going to start with what I see in the top left. Okay? Homozygous dominant. And I have 1 out of 4. I put a comma. Then I have 2 out of 4 that are heterozygous here and here. And then lastly, homozygous recessive, there is 1 of them. Okay? With phenotypes, I see that 1, 2, 3 of them. Oh, oops. My apologies. I'm going to go back. 3 of them. Oh, I did it again. Sorry, guys. I'm learning how to use this pen. I appreciate your patience. 3 of them are going to be pink. And then we also said that white was the other phenotype that we're comparing, and that would be 1 out of 4. Okay? So if I ask you a question and I say, what is the chance in this particular cross right here, so heterozygous by heterozygous, what would be the chances that my offspring would have a white flower? Okay? That would be a challenge question that I would have for you. Hopefully, by looking at this information here, okay, white is a phenotype. If I look right here, it's 1/4 or 25%. Okay? And so what we can do is we can actually use Punnett squares to come up with percentages as well as other important information as to how likelihood traits are going to be passed on. All right. So thank you for watching. This was an intro to Punnett squares, and I hope that this was helpful.